Hey everybody, good afternoon. Zoe, wonderful overview of food and food tech and ag tech. That was exciting. And I'll share where AeroFarms fits in. And we're a vertical farming company. And we have a video. This is of our 8th farm, and then there's going to be images. That's of our 9th farm that we built, the largest vertical farm in the world. That's in Newark. So if you want to try some of the product outside, it was grown in here. And it's sold in New Jersey and Whole Foods and ShopRite, here in New York City through Fresh Direct, through a brand called Dream Greens. But not here to sell Dream Greens, more to tell you about our interaction in ag and tech. So here, we could grow a plant using, on average, about 95% less water. We do that, well, so first, I'll start off. So 95% less water, 0 pesticides, herbicides, fungicides. Our productivity per square foot over a field farmer is about 360 times higher, up to 390 times higher than a field farmer. In New York State and California, it might be about 130 times higher because of the crop production. So we could grow a plant in average 15 days. A year ago, that was 16 days. Just through data analytics, data science, we were able to actually bring it down, just using the same seed, just giving it what it wants, when it wants it, how it wants it, to now in 15 days. So that's 23 crop turns a year versus, given seasonality, 3 in the field. And ultimately, this enables fresh food 365 days a year. We've grown about 400 different varieties of plants, and we think we could grow anything. It doesn't mean we grow everything. We really have a careful lens on what the economics are. Right now, the economics work best in leafy greens. Specifically, we grow baby greens, we grow herbs, microgreens. All these designations are basically maturity. It's when you harvest. When you eat salads, that's baby greens, and that usually has the best sort of texture and flavors and nutritional density. And my biggest surprise in this journey, I'm not from the farm industry, I grew up in the Bronx. We do farm in the Bronx occasionally, but my biggest surprise is we could influence taste and texture. So here, just like if we eat differently, sleep differently, exercise differently, that changes our biochemistry. In a similar way, if we get a plant to eat differently, sleep differently, exercise differently, and as weird as it sounds, that's what we do. We manipulate these abiotic stresses to influence plant growth, so we could influence these taste, textures, nutritional density, shelf life, color, texture of a plant. So for example, I brought 3 specific leaves here outside. So a kale, an arugula, and a mustard green. And here, if you try the arugula, you will taste the pepperiness. If you try the kale, you'll notice that unlike traditional kale, it's a softer leaf. Also, it's less bitter. If you try the mustard green, you'll see that it tastes like mustard. And we, to illustrate like the data analytics, we'll take the same seed, grow it lots of different ways. So give it lots of different types of spectrum at different intensities, different frequencies, different minerals and elements. So on average, there's, let's say, 20 different minerals and elements. We'll focus, like, let's give this one more iron, this more zinc, this more magnesium, et cetera, and see what the influence of the plant is. Let's change the temperature, the humidity, the pH, the airflow, the CO2. So the air in AeroFarms refers to aeroponics. So we mist nutrition of the root structure to give it healthy oxygenation of the root structure. So to give you an illustration of like what our team looks like, so we're 130 people, most of which have a tech background. We have plant biologists, physiologists, pathologists, molecular biologists, microbiologists that are looking at what all these different changes in the plant do. So how, when we mist nutrition and create the right oxidation, what does it do to the physiology of the root structure, and how does that influence plant growth? At the same time, we have all these engineers, so we have mechanical, structural, electrical, industrial systems engineers, all these engineers that are constantly looking at reducing the CapEx, reducing the OpEx, and understanding what's the right mechanical system to grow a plant of different types of varieties, whether it's leafy greens or something very different. And then we're constantly with the lens, since Dave asked me to kind of share from the environmental standpoint. My inspiration in building this company was reducing water. This was not a cost savings initiative. This is just more ambitiously environmentally minded. How do we do this? And our design principles are very much woven in the concept of doing more with less. So there's a lot of IP in filtration. How do we leave in nutrients and micronutrients? How do we filter out algae? Here, from an environmental standpoint, like we don't have to wash the food. When you wash food, we don't think of like when it says triple washed what that means, but it's all the pesticides, herbicides, fungicides we want to wash off. So we developed a way to grow with 0 pesticides, so there's nothing to wash off, so it has a very pristine flavor. Same thing with spectrum. Like, what's the energy hog of spectrum? Does it optimize photosynthesis? Can we strip it out? So it's why one by one our growth media is a cloth that's made out of recycled materials that's reusable. So very much kind of working as we build the company to improve our footprint on the environment. I see I'm out, so I'll leave it there. Thanks.
You.